This FedGov Today program is sponsored by Synack and Carasoft. On this edition of FedGov Today with Francis Rose, the supercomputers of tomorrow get a preview today, busting the status quo to modernize the Defense Department and leveraging the AI gold rush for your agency's success. Welcome to FedGov Today with Francis Rose. Computing power in the federal government's about to take a huge leap forward. Several federal agencies are either testing or using the next generation of high-capacity computers. Ann Dunkin is the Chief Information Officer at the Department of the Navy. Ann, welcome. Thanks for joining me. I read on the DOE website about 3 different terms that I want you to explain: supercomputing, exascale computing, and quantum computing. What are they? What are the differences? And what are the applications, Ann?
So that's super easy, Francis. And by the way, it's great to be here again.
Thank you.
So supercomputing is almost what it sounds like. It's like really big, fast computers. It's high performance computing. I've never found like a very specific definition of supercomputing, but it's sort of the biggest, fastest ones we've got there. Exascale computing is a very specific thing, and it is it's 10 to the with 18 zeros. So 10 with 18 zeros, number of flops. So that's a really big number of processing. So let me give you something that says, well, maybe something a little bit more reasonable. So imagine that you can do 1 mathematical operation per second in your head.
Okay.
Okay.
That's a stretch, but okay.
An exascale computer can do 1 quintillion calculations in the time that you could say 1 Mississippi. And maybe that's a little more understandable, but it's just a really fast computer.
Okay.
And it's a totally different architecture than computers that came before it, which means programs have to be written differently for it. So Frontier was the first exascale computer. It's also hard to say. Frontier is the first exascale computer. It's at Oak Ridge. And there are two more computers following on. Right? There's Aurora, which is now up and running, at least in test mode, at Argonne, and then also at Livermore they have El Capitan that's coming up. So lots and lots of exascale computing coming online out there. And then your last question was quantum.
Yes.
So on a small scale, matter exhibits the properties of both particles and waves at the same time, and we take advantage of that in quantum computing. And please don't ask me to explain any more physics than that, because that's my limit of physics. But basically, those characteristics of particles at that level allow us to do computing that's much, much faster even than what we've got already. And it requires you to super cool the material that you're going to use. And so we need really specific facilities to do that. So quantum is going to be something where you're not going to have a quantum computer in your desk, but you may get quantum as a service from someone like Amazon or Microsoft in the future, or maybe one of our labs. So DOE does a lot of work in high-performance computing, both leadership computing, which is about making high-performance computing better, which is why we do things like these new exascale systems, and then capacity computing. So let me back up a little bit and say capability is that leadership computing, making it better, and then capacity is just more computing power. So we do both those things to support our research in other topics, as well as to do research in high-performance computing, and we are taking that on to the next level of doing research in quantum computing, which allows us to then drive our mission further with more computing capacity and capability.
As somebody who was an English major and a C student in Algebra 2 in 9th grade, a lot of that I didn't get, but the parts about the power, the capacity and capability are very understandable. What are some of the applications that you're using some of this computing power for within energy? You mentioned some of these computers live at some of the labs, and what are some comparable capabilities that you're seeing across the federal government, Ann?
Yeah, so we have the biggest, fastest computers in the government. You know, don't tell the other departments and agencies, they might get jealous.
I think you shouldn't have said that on television if you didn't want them to get jealous.
Yeah, I guess that's true. No, seriously, we have often, you know, more than half of the top 10 computers. So many of the folks doing really important computational work across the government actually use our computers. So we're great partners. And we love working with departments and agencies across the government. We also support research outside DOE. And you can do research on DOE's computers for free, or you can pay, depending upon whether your work is going to the public domain or not. That's generally a generalized statement about what happens there. So in terms of what we do at DOE and our research agenda, so the reason we have these leadership computers, the reason we're looking at quantum computing is because all science is computational now, right? Even if you're doing bench science, you're doing computation to support that work. So, for example, if you're trying to identify new materials for batteries, you're going to use a computer, a high-performance computer, in the future maybe a quantum computer, to reduce the number of candidates you're going to look at, and then you'll go to the bench and do your actual research work. So if you take that, that's one area, that bench science. Another area is simply modeling. We do a tremendous amount of modeling, whether that's to support, again, that bench science, or to model something that we're just modeling. So for example, we model climate change, we model weather, which is different than climate change, because weather's now, that climate change is long term. We model the grid, and we model the systems on the grid and the risks associated. So for example, we might model wildfire risk and look at the grid based on wildfire risk and say, if we harden these three things on the grid, we can reduce the risk of a power outage in this area. So we can target where to invest in the grid by doing that modeling. We use these models to optimize wind farms. So you can't just put all those turbines out there. You need to understand how weather patterns affect them, and also how each turbine affects the next one. So you might run this, you might set the angles of where they're placed differently, and then you might run them at different power to get the most optimum use out of those. So those are the kinds of things we do, and that's like 3 examples, and we just go on and on with the things we can do with high performance computing. And the current exascale computers that we have now, and quantum will just increase that capability.
Are the risks at computing, risks in computing at this power level the same as what a government agency does on a day-to-day basis? I know you do this on a day-to-day basis, but you get my point, I think. So
cyber risks, all risks, what do you...
Any risks that are out there, what does the landscape look like?
Okay, so I think there's a couple things. So one is, obviously they take a lot of power. So our risk of losing power in some levels is higher, but on the other hand, we have our own power. We have, sometimes we have a substation. We certainly have multiple redundant feeds, so that we're getting power from 2 different power companies, or at least 2 different locations. But we have to have lots of power, we have to have lots of cooling. We're doing some really cool things, like at NREL in Colorado. NREL is almost 100% efficient, so they have very little power loss. And for example, they take the heat from the supercomputer out there, and they use it to heat the building. And then they bring back cooler air to cool the supercomputer again, heat it up, heat the building some more. So we find ways to reduce our environmental impact in that way, but we use a lot of power, we use water, and we have to have all that. So that's one risk. Obviously, there are security risks, which is where I immediately went when you asked me that question, as you asked me about cybersecurity. And high performance computers are different, and we have to apply different security controls to those, because some of the security controls we might apply to an enterprise computer will actually slow down the high performance computer and therefore interfere with our mission. So we have to look differently at how we secure those. We actually have a group led by a guy named Ian Lee out of Lawrence Livermore, who looks just at that. How do we secure high performance computers? And we actually are going to have conversations on that topic at the conference at SC24 coming up. So that's a great example of where we're trying to solve that problem. We also recognize that we have a lot of people working on those computers, and we vet them, but they are not vetted the same way we vet federal staff. So there is always a risk of our own type of insider threat when we look at HPC.
And Duncan, great to have you on the program. Thanks for the insight into supercomputing. I appreciate your time today.
Francis, it's always great to spend time with you. Thanks.
You can read more about supercomputing across the federal government on today's show page at fedgovtoday.com. Up next, busting the status quo to modernize the Defense Department. FedGov Today with Francis Rose continues in a moment.
Civilian federal service follows countless paths, each road unique, each journey distinct. WEPA has covered them all since 1943, from the demands of the job and accomplishments at work to the joys of the family and milestones at home. From inside the office to beyond the Beltway, Group Term Life Insurance from WAEPA has the coverage and benefits to protect you and your loved ones wherever Fed life leads. WAEPA, for Feds, by Feds.
Welcome back. A new edition of the guidance document, DoD DevSecOps Fundamentals, is out from the Office of the Chief Information Officer at the Department of Defense. DoD IT leaders list DevSecOps as an important part of their modernization efforts. Katie Bowen is General Manager for Public Sector and Defense at Synack. At DODAS 2024 in Omaha this week, she tells me the organizations in the defense sector that are modernizing well are challenging the status quo.
Particularly where speed and security look like they're at odds together. We've seen that with some of the software factories and some of the really great successes that have come out of there. Those organizations are also measuring cycle time. They're measuring MTTR and other key indicators of software quality. And cyber plays a big part into that as well, of course, considering that those systems and pieces of software are being delivered to the warfighters in the field and sometimes on isolated networks.
If you say they're measuring cycle time, does that mean others aren't, or do you just mean that that's a really important part of success in this area?
I'd say it's a really important part. I'd say, it's easy to measure a million things and never really know where the signal and the noise is. You read books like The Unicorn Project and Accelerate and others, and you get so many great ideas on things to measure, but you really have to refine and continue to refine the things that you're measuring and make sure you're measuring the right things. Yeah.
Is it important to pick just a couple that are important to the outcome that you're trying to achieve? Is that what you're going for there?
Yeah, those indicators that are keys of mission success, right? I mean, every mission has different objectives. Some of them are short-term, some of them are long-term missions. And it's really about evolving that so you're delivering for your stakeholders at large. And, software is such a big part of what we do every piece of our lives today. And delivering quality software is important at speed and scale.
Yeah, at speed is an important term. Is there a right speed? Is it possible to go too fast for organizations that are just trying to really crank it out?
Yeah, I think it can. That can happen. Everybody talks about how Amazon.com is, they're running blue-green deployments on us every day, every couple minutes. I think that's important for a commercial organization like that to be able to deliver. But I think there's also that question of, are we building the right thing? And are our users going to love it? And it be useful and usable to them as well. And then, of course, security is inherent in everything we do. Is it secure? What are those key measures of software security? And through that pipeline and supply chain, we're hearing a lot about SBOM lately. We're hearing a lot about CMMC and other important pieces to delivering software securely through that supply chain.
Mm-hmm. You talked at the beginning of this conversation about the software factories and some of the successes that those organizations are having. Is there a point where that concept will proliferate so much where it kind of becomes the de facto way of doing business? Or are we starting to maybe already get to that point?
Yeah, I think, those software factories were started because something needed to be started outside of the antibodies of the organization, right? And we talk a lot about culture because at the end of the day, the tech is easy, it's the people. And we're all people. So I think, key decisions will have to be made about how to consume those factories or those factory outputs or abilities to collaborate at that level back into the organization and just have it be a new cultural way of working.
Mm-hmm. What do you see moving forward as the biggest challenge, integrating new tech? Everybody wants to talk about artificial intelligence. It's great, but the issue is not so much, it seems to me, AI as it is integrating into what we're already doing, both from an infrastructure perspective and a business process perspective. What do you tell folks? How do you help folks understand how to think about that idea?
Yeah, I think it's the old, go fast, go slow to go fast, right? We need to think really strongly about the guardrails we're setting up, with it for AI in our organization. We get asked a lot of how are you testing the security of AI, not just the peripheral services, because the models themselves are inherently secure for the most part. It's the chatbots and the things that we're building around them that have security concerns. And then you layer on bias with that and how you want your organization to respond. Should it be asked a certain thing a certain way? And that becomes inherently more complex. Mm-hmm. I think that's all part of, how we work those tools both internally and externally into our daily lives. And those are all considerations that security and software leadership should think about before they implement at scale.
Katie Bowen of Synack. You can read more about DOTIS 2024 on today's show page at fedgovtoday.com. Busting forced labor rings and a space microphone are just a couple of the programs keeping winners of this year's Arthur S. Fleming Awards busy. You can learn more about them and about this year's Fleming Awards on this week's edition of the FedGov Today podcast. You can listen anywhere you get your podcasts and always on demand at fedgovtoday.com. Up next, leveraging the AI gold rush for your agency's success. FedGov Today with Francis Rose is back in a moment. The new TV show Better Contracting, Better Outcomes is available on demand now at fedgovtoday.com. You'll learn from top executives at NASA, DoD, Social Security, and more, plus industry experts that are leading government-industry partnerships. Discover their strategies for improving acquisition efficiency, achieving mission success, and driving innovation through federal contracting. Better Contracting, Better Outcomes, presented by the National Contract Management Association. Watch anytime at fedgovtoday.com. Welcome back. The federal government's in the middle of an artificial intelligence gold rush, according to one agency chief data officer. Lori Wade is the CDO for the intelligence community. At DOTIS 2024 in Omaha this week, I asked her what that term means to her and how organizations in the federal government can leverage the gold rush.
We're viewing semiconductor as the pickaxe and the shovel, that we're just going to go up and gather up all the data. And all of the investments that we see being made in the private sector, understanding that in the first 3 months of this year, $32 billion was spent on commercial data center architecture, right? There's a lot of money being spent on compute. All of that is being spent on just a portion of everything that needs to be done to be able to scale AI. And so I call it the AI gold rush. I saw that in a magazine, actually, and I loved it because I thought, it's right. We're out there trying to dig up the gold without a plan and without making the full investment. And so what I see happening with everything that's going on across the U.S. government and the intel community, we've become enamored with the technology side of it and all the glitz without really understanding what are all the foundational pieces that need to be in place. And so I know we need to innovate, but do we have to do it at the expense of all the other foundational elements? We should be investing in all of it across the board at the same time. The data, the infrastructure, every aspect, skilled workforce, right? There's a lot of work that is still human in the loop, and we have to have the skilled workforce to be able to do that work. Prompt engineering, building the algorithms, taking the models that exist in the open and bringing them into the intel community. None of that has been trained on intelligence community data in that context. So that's work that has to be done. And then all of the privacy and civil liberties, PII, Attorney General guidelines, everything we have to do to the data that has to be tagged and labeled from an intel maximum use of that data throughout its life cycle, that work has to be invested in as well. So let's not get caught in the AI gold rush. Yeah. And then how do we make sure that those investments we benefit from?
The workforce issue that you mentioned, are there enough people to do the things that you need them to do to maximize the potential of the AI gold rush? Or is this going to turn into a similar situation with the cyber workforce where you and your colleagues in government are competing with the private sector, the companies that are here and others, to try to get all the same talent? Everybody's going after the same people.
I think this is a global issue, really. I think every government, every private sector, this is something that we have to focus on. It's one of the focus areas of the IC data strategy. It's something I spend a great deal of time thinking about. How are we building a future workforce? How are we attracting them? How do we get the skills that we need? How do we leverage what's being done in the private sector? So maybe we don't need to bring all of it in, all the expertise in, but how do we leverage it in a new and different way? But then also, how do we build the acumen and the data tradecraft of the workforce that we have. We're working internally with the National Intelligence University on a curriculum. We're looking at all the different schools that across the intelligence community. The DoD, we work a lot with our DoD colleagues and partners. And then we are branching out. We just recently, I think I told you about this earlier, we just awarded UVA to stand up, the University of Virginia to stand up a National Security Data and Policy Institute, and it's housed out of their data science program. So we need to be thinking this all the way through. And then how early are we starting to develop that skill set? Not only just in universities, but if we even went back to K to 12, we need to be thinking of it from a whole of government view of where we're going to train and bring up the skills that we need to do this work. And by this work, I mean to scale advanced analytics across the intelligence community enterprise. Takes data professionals, technologists, it takes a whole team of people. It's a team sport. So we have to be working across those with my CIOs, CISOs. This is cybersecurity aspect, there's the IT aspect, there's the data aspect, and then there's the mission aspect of all this. So it takes everyone across that full spectrum.
That partnership with UVA, what does that involve, and what will be the end result benefit to you? I imagine it's mostly good people coming into the workforce, but also to UVA. I imagine a partnership, they'll benefit in some way also.
I think so, because what we're going to bring, and we're just kicking this off. We haven't even had the ribbon cutting yet. So this is brand new, hot off the press that we just put a press release out recently on this partnership. And we are starting with some defined mission challenges. A lot of people would refer to those as use cases. I like the word mission challenges, and how we're going to do a mission sprint related to these. Real challenges that we're having, and a lot of the early mission ones are related to econ warning, emerging tech. How do we take that into a university where we're looking at what are the data policies, data privacy, data innovations that we can bring to bear on not only that data that's available in the open, but then how do we bring that back into the intelligence community? So we have a set of requirements. We're working with the UVA team. Once we work out how that's going to do, then they'll be the channel it back into the intelligence community.
You said recently that too much data is a liability.
Right.
What does that mean, and how does that concept inform the way that you are structuring the data posture of the IC, Lori?
So in the IC data strategy, I talk about end-to-end data management. And I have spent a great deal of time in this role getting the intelligence community to understand that we're a data organization, right? And end-to-end data management. So in June, the ODNI signed the Intelligence Community Directive 504 on data management. So from the point of collection all the way through to exploitation and dissemination, and also we have to worry about disposition. How are we planning across that? What is the total cost of ownership of our data? I've been working with the intelligence community CFO, Chief Financial Officer, on a methodology so that we could start to code that data. Because in our world, right, a data organization, if we talk about data being a strategic asset, well, it's only an asset if you manage it well and you manage it throughout and you understand, was it collected for or purchased for a purpose? Are we using it for that purpose? And then how are we managing it throughout? Because there's a cost associated with that. And then that's where I get to, if we don't manage it well, then it's a liability. It's a liability because we talk about zero trust architecture and cybersecurity, protecting the crown jewels. The data is the crown jewel for us. And if we don't know what data is in the system and we haven't tagged and labeled that data and it walks out the door, it's a liability. So it's a cybersecurity, insider threat, liability. Also, the cost. Keeping large volumes of data, trying to process large volumes of data, is compounding in costs because of index, compute, and storage costs. That's why we just released the data reference architecture to look at how are we leaving data where it lives in a distributed ecosystem, because we have a habit of moving data around or duplicating it for use. Well, that has a cost associated with it. So the liability comes in, more data doesn't equal better, right? So we have to think about the data all the way throughout its life cycle and how much that's costing us. And then also, people want our data, so they're going to come after it. So if we don't know the data we have and we haven't marked and labeled that data in the systems, then that's all the ways it can become a liability.
We have less than a minute left. Is collation or curation the biggest key to determining whether liability or asset is the classification that one's data is in?
Wow. I mean, for us, I think it's got to be both. It's dual focus for us. If you think about our missions across the IC, we have to be focused on both of those aspects.
Lori Wade of ODNI. You can read more about AI in government on today's show page at fedgovtoday.com. FedGov Today continues in a moment.
For me personally, on the military side, I think any conflict in the Pacific probably starts in Charleston, South Carolina, and moves westward across the United States. And along the way, you have dual-use critical infrastructure supporting that military deployment until you can get it into the Pacific, into the fight. So I think the military holistically has started to look at where that dual-use critical infrastructure is, and started to really map out where they can come in and support from a visibility standpoint. And so I think it all starts from gaining visibility into where that infrastructure is going to be necessary. And then from a cyber perspective, really getting into helping the critical infrastructure provider get into the network to start to understand where their vulnerabilities are, and then help them through best practices to harden their networks.
Welcome back. In today's event spotlight, the ACT-IAC CX Summit is one of the biggest customer experience events of the year in government. It's coming this Friday, November 15th, at the Hyatt Regency Crystal City. Doris Consulting will partner with ACT-IAC on the event. You'll learn from CX experts from across the federal government and industry. You can read more about the event and register at fedgovtoday.com/events. FedGov Today TV returns next Sunday morning at 10:30 with Brigadier General Melissa Stone of Cyber Command and the Defense Intelligence Agency's Chief Information Officer, Doug Casa. I'm Francis Rose. I will see you then. Thanks very much for watching. Have a great week. If you want insights from agency and industry leaders on the latest topics in technology, management, workforce, defense, and acquisition, sign up for the FedGov Today podcast with me, Francis Rose. I release new episodes every Tuesday and Thursday, so you'll stay up to date on the issues that matter most to federal government leaders. Listen at fedgovtoday.com and everywhere you get your shows. Don't miss out on the conversation. Follow the podcast today.